Have you ever heard about interrupt controller? The interrupt controller is terminology that is a combination of interrupt and controller. What the interrupt controller does is to identify the interrupt signal from external devices or peripheral device. So if you refer to any reference, the manual reference documentation of the chipset, I'm sure that you will see the interrupt controller inside your chipset. In order to understand the primary feature of interrupt controller, then we need to think about three important components in your embedded system. Every time you look into some of the reference manual of your system, then you will see that there are primary three components. First component is CPU, and a number of the embedded system is based on the ARM processor. And then another important component is memory, and then memory is storing the data from the CPU processor, and then without the memory, an embedded system is unthinkable. And another important part of your embedded system is external I/O devices. We call external I/O devices as the peripheral device. Let's suppose that you are generating some idea of your own the embedded device. In this case, you should consider several peripherals that will be embedded in your system. Take for example, sometimes sensor peripheral should be included in your system. Then in some cases, your external another and sensor and touch and UART peripheral can be attached to your system. Another well-known external device is mouse or keyboard. Those kind of peripheral device is interfaced with the CPU processor using interrupt. So that is the main reason why we need interrupt controller. They take this interrupt signal, identified interrupt signal from those kind of external devices, and then the interrupt controller can generate some of the policy, or interrupt controller makes some of the priority for various interrupt from the peripheral device. That is the main reason why interrupt controller is introduced. Now that you have understand why interrupt controller was introduced, let's think about workflow of interrupt controller. In the diagram, interrupt controller is placed nearby the CPU processor, and this box is interrupt controller. Here, this box USB and sensor and keyboard, those external device is peripheral device. Then USB and sensor, keyboard, peripheral device signal interrupt when there are some changes at the hardware level. For example, if you connect USB cable to your smartphone, in this case, an USB interrupt is generated. And if your sensor in your smartphone signal interrupt in this case, and then also in this case, interrupt controller will identify the signal from sensor. Then if you put your finger on to your keyboard, and keyboard peripheral will generate interrupt. So main job of interrupt controller is to identify the signal, interrupt signal from those kind of peripheral device, and then interrupt controller will route this interrupt information to the processor. That is the main job of interrupt controller. Then as you can see in the slide, the NRAQ and NFIQ can be identified. in generally, and most of the interrupt signal can be generated as a form of IRQ. IRQ is the terminology at the software level. So if your peers tell you about IRQ is raised, and then you can see that you understand that interrupt request is delivered from interrupt controller. And another type of interrupt request is FIQ. In general, FIQ is considered fast interrupt IRQ request that is higher priority than IRQ. So if you consider that interrupt is identified from interrupt controller, and then right after interrupt controller, they reroute the interrupt to the CPU core, and then during this operation, IRQ is generated. So if you like to control your peripheral device in more detail, I think that understanding the interrupt controller is extremely important. In summary, and let's understand the feature and role of interrupt controller. Main job of interrupt controller is to collect, manage the interrupt generated by external I/O devices and send them to the CPU processor. Then external I/O devices could be sensor, keyboard, and USB devices. So when you are in the situation to implement your own device driver in Linux kernel or real-time operating system, then I think that your main job is to add the piece of code to control your own the devices. Then the routine of device driver include interrupt service routine, because most of the peripheral device interact with the CPU core using interrupt. So software stack, the implementation of the interrupt service routine is going to be the interrupt controller, interrupt handler for corresponding interrupt. So this is important, the job of the device driver developer. So that is another important information we can refer to.